If you'll have out worksheet 4, 5, and 6 and the trig identities sheet. We're going to continue to do topics like we have been as far as trig trades, but we're going to today do ones where I give you the answer, okay? It's called a proof because I want you to make one side look like the other. It is not a proof in that you have to give statements and reasons like you did in geometry, okay? It just means you have to work with one side until it looks like the other, and you have to show your trades. So we're going to start on worksheet 4A, I think kind of in the middle of the page, if I remember right. The learning targets for today are to combine trig expressions by getting a common denominator and simplifying to a single fraction, or to verify a trig identity by working with one side only to prove the identity is true. All right, so easy one to start with. What could you show me to make this equal 1? You can work with either side, but on one like this, it clearly makes sense to me to work with the left side to simplify it down to a 1. Okay, so I wouldn't trade anything for sine. But what could you trade cotangent for? Cosine over sine. And then you could show me that you're trading secant to be what? 1 over cosine. And then it's fine to just, you can write equals 1, but sometimes that right-hand side is a lot of work to copy down over and over and over, so I just leave it. But then show that this would simplify here by canceling or dividing out to become 1. This would divide out to become 1, so we're left with 1. And then you can either copy that right-hand side down and say, yep, I proved it, or if it's a lot of messy stuff over there to copy down, sometimes teachers just use right-hand side. I made the left equal the right-hand side, okay? We'll see some eventually where there's a lot of stuff to copy down and you don't want to mess with it. Writing equal 1 seems pretty easy. All right, underneath that is another one. Now, this one's a little more complicated. Does anyone know how we could trade out? First of all, do you want to work with left side or right side? Doesn't matter at all. So we just keep working with the left? It isn't going to matter. What could we trade for a sine squared that would get us to have a cosine squared? Can you look at, because they don't want us to have any more sine squareds, so can you look at your trig identities to figure out what trade we could make for sine squared? Okay, first of all, you can't combine the 1, it's like a positive 1 minus 2 times a sine squared. But what could I put in place of a sine squared? Well, there was one that said cosine squared plus sine squared equals 1. So what could we make it say? I want to get rid of sine squared. So I want this to say equals sine squared. So what do I want to do with that cosine squared? Subtract it over here. So I would have 1 minus cosine squared. Okay, so I wanted to make the left-hand side look like the right-hand side. So I found a trade for sine squared, that being 1 minus cosine squared. Okay, off the trig trade sheet. Everybody with me? All right, what do we need to do next? Algebraically, what do we need to do to this? Yeah, let's distribute this -2. So it's 1 minus negative 2 times 1 is a negative 2. I'm sorry, it's just minus 2. Sorry. And a negative 2 times a negative cosine back there would become what? I know this is a quiet class, guys, but help me out here. What's negative 2 times a minus cosine squared? Positive 2 cosine squared. Everybody good? So what happens? Combine like terms and we get a negative 1 plus 2 cosine squared. Is that equivalent to this right-hand side? Yeah, we could just change the order if we felt like it. If you didn't even bother, I would be okay with that. Oops, I forgot the theta. Okay, which was the right-hand side up there. Is anybody confused about what our goal is here? To make one side look like the other? Does that seem okay? All right, at the top of 4B, there was one question on this verifying stuff. Any suggestions here? I got a hint for you. Can you look at the bottom of the last page? What was the bottom of the last page covering? Was the very bottom show? Oh, it had factoring. The example before this that we did the other day was on factoring. Is there anything we could factor here? Cosecant squared minus cosine squared times cosecant squared. We don't have to do it this way. We could trade it to sines and cosines and we'd get the same answer. Do you want to trade it to sines and cosines or do you want to factor it? Which would most of you have tried? Okay, well, let's try sines and cosines then. And then I'll show you the factoring way. If we trade it to sines and cosines squared, cosecant squared is 1 over sine squared. And this one is a cosine squared times a cosecant squared, which is a 1 over sine squared. What does that become? They already have a common denominator then, right? Can you just extend that? What do you do when you have a common denominator? You're adding or subtracting? Combine the top, keep the bottom. Whew, must be Monday. You guys are really quiet. What is a 1 minus cosine squared? I think that's a trade we just made, or one that was related to one we just made. A cosine squared plus a sine squared equals 1. So a 1 minus cosine squared is a what? So the top trades for a sine squared. So what do we end up with? That divides out and we have 1 equals the one that was way up there. I don't know that it's any better. I don't think it's any better, but if you had factored, guys, you could have taken out a cosecant squared. Does everybody see that? If I took a cosecant squared out of a cosecant squared, I'd have a 1. If I took a cosine squared, cosecant squared, and I factored out the cosecant squared, I'd have 1 minus cosine squared. Okay, that was by factoring. What is a 1 minus cosine squared? We did it right here. It was a what? Sine squared. So then we would have wound up with this. Do some of you recognize that that is a 1 over sine squared times a sine squared, which would have made it 1, okay? So that was the factoring way to do it. Would I count either one, right? Absolutely. Anything you do that doesn't break the laws of algebra or the trig trades that gets you to this at the end will be fine. All right, let's try, this says 5b, okay? It says go back to 5b, but that's because I was originally going to do the top as a warm-up. Then I realized I'm going to save those top 3 for review for the quiz later. So we're going to go to 5b. All right, try this one. You guys try it on your own. Or somebody tell me what to write. It's all supposed to simplify to 1, so it can't be that bad, right? What's a tangent? What's a cosecant? Does everything divide out like it says it should? Could you handle that one as a proof? Okay, make sure that you have those memorized, those ones that aren't on the trig trade sheet, the reciprocal functions. All right, what do you want to try here? This one's trickier, but there are some like this on the, yeah, I would. The suggestion was that we double distribute or FOIL this side together. So sine times sine, anybody? Sine squared of theta. And the outside 2 is a plus cosine sine. Then the inside 2 is a negative cosine sine. And you can write it sine cosine or cosine sine, it's the same thing. And then last term times last term, anybody? Yes, a minus cosine squared. Now, is a sine squared minus a cosine squared 1? Be careful. It's a plus, right? It's got to be plus. So that's not going to do us any good. What happens in here, though? Yeah, so we're left with a sine squared minus a cosine squared. We're trying to get it to say 1 minus 2 cosine squared. You don't have to copy that down there if you don't want to. So what do I not want to have anymore? I don't want a sine squared. What could I replace a sine squared with? I feel like we've done this trade already twice today. 1 minus cosine squared. Okay, sorry. That is a 1 minus cosine squared. And there was already a minus cosine squared. So what's going to happen? 1 minus 2 cosine squared. Okay, I think there's a couple more here. This one looks really messy, but it's a weird start. It's like they gave us a hint. Because what is the point in this? That's just 1, right? So we could get rid of it, but I think it's their hint. that we're going to need it, because do you see how it winds up with a 1 minus cosine on the top here? So I think we shouldn't just get rid of this. I think though that the top I will just leave sine theta times 1 minus cosine theta, because it looks like we're supposed to end up with a 1 minus cosine theta, so I don't think I want to distribute that. When you multiply, you just multiply the top and you multiply the bottom. Rather than copy this all down again, can we go ahead and do what to the bottom as we multiply those together? Can we FOIL that together or distribute that? What is a 1 times a 1? Then the outside would be a minus cosine theta. Cosine times positive 1 in the inside here would be a plus cosine theta. And then the last term here times the last term here would be a negative 1 cosine squared. Anybody see where we're going with this? What happens in the middle two terms here? So I have a sine and a 1 minus cosine theta on the top. I mean, I guess we could rewrite it as 1 minus cosine squared, but does somebody know what the trig for that is? I feel like we've used it 3 times today already. Right, the trig says sine squared plus cosine squared equals 1. So a 1 minus cosine squared is a sine squared. And as it is a proof, you need to show all your steps so that I can follow what you did. Then what happens? Is it killing kitties to cancel one of these signs right here? Everybody's scared to speak. If we have this, we can't cancel one of those, right? Because this is involving addition and subtraction. But does this involve addition and subtraction out here? No, it's multiplied. So we can divide out one sign here with one of the signs down here, which leaves 1 minus cosine over sine. Is that what we were trying to get to? Okay. This is where it's kind of messy to have to rewrite. So some teachers will just say, let's just write it's equal to the right-hand side up above. That's what that stands for, right-hand side. Because you're too lazy to rewrite it. I don't care. You can do either way. Any questions? All right. Now, some of you are thinking distribute here. I see parentheses, and we could distribute, and we'd get the same answer eventually. But is there a trig we know for 1 plus cotangent squared? Can you look on your sheet? 1 plus cotangent squared is a cosecant squared. So then what is that? What's a cosecant? It is a 1 over sine, so does that become 1? All right, if you had not done that, let me just show you the other way. If you had traded it to cosines and sines, and then you had distributed, you would have wound up with a sine squared plus a cosine squared, which is what? 1? Okay, so you should have gotten it either way. All right, top of 6A, I think. Okay. This is the last of our examples. Oh, what do you want to try here? I think I want to work with the left-hand side, right? Because it looks real messy and I want to simplify it down to match the right-hand side. But any ideas what we could do? There's two options that come to my mind. One is switch over to sines and cosines. But the other, does anybody remember we did a little of this when we had, it was stuff like this. We talked about separating it. Okay, long as you have one denominator, you could go back to separating it. I don't know that that's a good idea. What do you want to try? It'll get the same answer either way, I promise. Separate it or do sines and cosines? Which would you have done? You want to separate it? Okay. Secant over secant minus cosine over secant. Okay? Which gives us what right here? 1 minus, now you want to switch to sines and cosines? The cosine is being divided by a what? And dividing means how do you get rid of divide? Multiply by the reciprocal. So that becomes cosine over 1. The other way to think of that is just you're going to multiply top and bottom by cosine, because that'll become a cosine squared over 1, which is what this is going to become either way. Okay, you can explain it this way or this way, doesn't matter. You get a 1 minus cosine squared, which is a sine squared from those lovely Pythagorean identities, which makes it equal what we had at the top. Anyone want to talk me through this one? We could, except it's a multiply, not an add in the middle. Okay. Usually when we're, yeah, I don't think we can separate this, because if we did, and we put them both over cosecant, and it's multiplied, that would be like a cosecant squared. Yeah, I was thinking, should we? Since there's no addition and subtraction, I guess I would just go straight for cosines and sines. There's no squareds, so we didn't want to change cotangent for anybody. You still don't know those, guys. It's going to be a rough quiz. Secant is, and cosecant is, wow, I don't think we have to do much. What happens up top? So I really just end up with a 1 over sine on top of a 1 over sine. That doesn't seem like it requires much work, does it? You could show me that you're going to multiply by the reciprocal. I don't care. You could multiply top and bottom by sine. Whatever you want to do, but in my mind, anything over itself is just 1, so you don't got to show a bunch of steps. All right, I think there's 2 left. I gave you a hint for the top here. What is a 1 plus tangent squared trade out for according to our sheet? A secant squared. So are we done? Thank you. Yeah, it's like we have an m squared over an m, right? It would cancel one of those and you're left with an m. So it's going to cancel one of those and you're left with a secant. Okay, and you don't have to show the right-hand side the whole way down. I don't care. Last one. What are you thinking here? Foil together the left side, and what does that become? Yeah, it does become a 1 minus cosine squared. I'll show all my steps, but if you didn't, I would be okay with that. Now, how did that become a 1 over cosecant squared? Anybody know? Okay, 1 minus cosine squared is sine squared. And then it's a weird trade, but sine squared is really the same as the reciprocal of what? Yeah, I don't know why we do that, but it is the reciprocal of cosecant, so we got it to equal the right-hand side up above. All right. I'm going to stop the video, but we can do any that you want together. Your homework is to do worksheet 6B. It says you have to do any 5, okay? So how many are on that page? Like 8? 8? Okay. So you have to successfully do any 5. So if you start on some of them and it doesn't seem to be going anywhere, you can stop and try a different. Does that make sense? All right, so I'm going to stop.